Hey everybody, Mr. Quick here. Today we're going to look at Eureka Math / Engaged New York Math, Module 4, Lesson 34, Writing and Graphing Inequalities. So we're going to look at inequalities, which is what we've been talking about over the last several lessons, and we're going to graph those. We're also going to look at inequalities where there are multiple answers and how to graph those. And I'm going to show you my little trick for how I remember whether to fill in the circle or leave it open. And I'll even tell you what those mean here right now. So we've got some statements here, and we're going to write the inequalities. The statements aren't related to any math problems. They just are statements, and we're going to write an inequality based on those. Here's an example. Caleb has at least $5. So the inequality would be, we'll put C for the amount of money Caleb has. Caleb's money is at least $5. That means it's $5 or more. So it's greater than or equal to 5, because he could have just $5 because it says he has at least $5. That means that was the minimum. Or he could have more than that. So we have C is greater than or equal to 5. Tarek has more than $5. Well, in that case, we'll say T for Tarek. More than, greater than 5, right? T is greater than 5. Vanessa has at most $5. So she has $5 at the most, but she doesn't have more than that. So we'll say V for Vanessa's amount of money. She has, and we know the other number's going to be 5. She has less than 5 or equal to 5. So Vanessa has less than or equal to 5. Right? So she could have $5, she could have less than $5, but she doesn't have more. So it's definitely less than or equal to. And then Lee Chin has less than $5. So we'll say L, and she just has less than $5. Now, if we were going to graph these, the graphs may look something like this. Okay, so we have 4 graphs or 4 number lines here. They all go from 2 through 8, because basically the only number we're really looking at here for all of these is 5. And so let's take a look. I'm going to write with red just so you can see. Normally you'd write with black, but I'm going to make it a little easier to see here. So C is greater than or equal to 5. So C is 5 or any of the numbers greater than 5. So I'm going to put my circle at 5, and I'm going to draw my arrow going in this direction, because all of those numbers, and then all the numbers even farther down that way that are not on the number line that I drew, would be included in the answer for C, right? That would make C a true statement. So 5 would make it a true statement, 6, 7, 8, 9, anything going in that direction. Now, here's a little trick. You'll notice that some of these are greater than or less than, some of them are greater than or equal, or less than or equal. This is my little trick. If it includes the number, so in this case 5 would be included, C could equal 5, then you fill in the circle. You make it a solid circle. And here's my trick to remembering that. If you have the less than or equal to sign, or excuse me, the if I could speak, greater than or equal to sign, or the less than or equal to sign, I like to think of that little line down underneath, which means or equal to. I think of that as a little pen or marker. And I think, okay, if it's got that little line down at the bottom there, I've got to fill in my space, or fill in my circle. Okay, so let's look at this next one. This is an example that does not have it, right? Tarek has more than $5. So Tarek has, we're going to start at 5, and he has more than $5. So it is going to go in this direction, because it could be 6, 7, 8, 9, or whatever. But you'll notice it doesn't have the line underneath. So I'm going to leave this circle whole, basically meaning that 5 does not count there. So he has greater than 5. It's not just 5. So then down on this next problem, if Vanessa has less than or equal to 5, we're also going to start at 5. But this time she has less than, so we're going in the other direction with our arrow. We're saying all the numbers this way would be part of our answer, and 5 would count here if I had a 5 instead of V. because it says or equal to. So that little line means I've got to fill in my circle. And when you see that, you know that 5 is included as part of the inequality. And then Lee Chin has less than $5. So there we're going to go to the left because all these numbers are less than, right? But we're going to leave the circle open, showing that 5 doesn't count there. Like if I put 5 here, $5 is not less than $5. That doesn't count. $5 is equal to $5. Okay, let's look at a couple of examples here together. Okay, Kelly works for Quick Oil Change. No relation. If customers have to wait longer than 20 minutes for the oil change, the company does not charge for the service. So 21 minutes and you get your oil change free, right? But you may wait up to 20 minutes. The fastest oil change Kelly has ever done took 6 minutes. Show the possible customer wait times in which the company charges the customer. So, first I'm going to create my number line here. Let's see if I can do a little bit of a straighter line. There we go. We'll start with 4 for some scale, and we're going to count by 2s. 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, just to fill it out. The reason I'm counting by 2s is if you counted from 1s, that'd just be so many numbers. It already looks pretty busy here, right? So you're going to get charged, you're going to get charged, that's right. You're going to get charged if it's 20 minutes or less, right? So we're going to start with 20. And basically, we'll say C for charged, right? If it is less than or equal to 20, you're going to be charged. It won't be free, right? And since we have that line there, we're going to fill in our 20. Now you might say, okay, so then you're just going to go all the way down here, right? That's partially true, but remember, Kelly has only ever done an oil change. The fastest he's ever been, or she's ever been, has been 6 minutes. So we know that we can also look at it in terms of putting a 6 over here, and we know that 6 is also less than or equal to the time that you're going to get charged because Kelly's never gone faster than that. So that's going to get filled in too. And we're not going to go less than that because we don't need to, because Kelly's never gone faster than that. So anywhere in between here, based on what Kelly can do, is where you're going to get charged. So this is what your equation looks like, right? You're going to get charged. C is greater than or equal to 6 because they've never gone faster than that. And it's less than or equal to 20 because they don't want it to be more than 20. Okay? So then when you graph that equation, you have numbers on both sides, and then you have to determine, does it just go between the two? Is one of them open or closed? And in this case, they're both closed, meaning that 6 and 20 are both part of the answers because we have the equal to signs here. All right, let's look at another example. Example 3. Gurnaz has been mowing lawns to save money for a concert. Gurnaz will need to work for at least 6 hours to save enough money, but he must work fewer than 16 hours this week. Write an inequality to represent the situation and then graph the solution. Well, let's take a look. Let's put X. We'll say X is how long Gurnaz is going to work, right? When it says he needs to work at least 6 hours to save enough money, at least 6 hours, we can then say, so the time he wants to work, which we're going to represent with X, is greater than or equal to 6, right? Because he has to work at least 6 hours, which is the equal then part, or more. However, he has to work fewer than 16. So he can't work 16. He has to work less than 16. So that's going to put us at less than 16 here, We don't have the line underneath because it didn't say he must work 16 or fewer. It just says he must work fewer than 16. So he could work 6 or more, or he could work less than 16. It's going to be somewhere in between there. So let's draw our number line, our graph here. Okay, and I'm going to go ahead and do this with a red just so we can kind of see. So I'm going to do this portion first. So 6, I'm starting at 6, and 6 can be included. He can work 6 hours. So I'm going to fill in the 6, and then I'm going to come over to this portion here, and I know he has to go less than 16 hours. So I'm going to go to 16. So the amount of time that Granaz can work is in between 6 and 16 hours. However, he can work 6 hours. 6 hours counts as part of the inequality. It counts as part of the answer, so I'm going to leave that filled in. He can't work 16 hours. It said he has to work fewer than 16 hours. So I'm going to leave that as an open circle. So we see, just by looking here, he can work 6 hours up to, let's call it 15.9, but he can't work 16. So somewhere in between there. Okay, we're actually going to do several more examples of these because I know these can be a little complicated, but I'm not going to have time on the video to do more. But we will look at more examples together, and we'll talk about how this works and how we can do these. So thank you for watching, and we'll talk to you very soon.